The Fibonacci sequence is found both in math and science, and it's a recursive sequence. And to be a recursive sequence, you have to start off with a start value, and then you have an equation to find what the other values in the sequence are. So for the Fibonacci sequence, our first value, f1, is equal to 1. Our second value, f2, is also equal to 1. And to find the rest of the sequence elements in the sequence, we do fn is equal to fn minus 1 plus fn minus 2. So to find the third element in the sequence, we do f sub 1 plus f sub 2 to find the third element. And as you can see, f sub 1 is 1, f sub 2 is 2, so we add them together, and we get our third element to be 2. So far, our sequence is 1, 1, 2. To find our fourth, we then do f2 plus f3. And f2 is 1 plus f3 is 2 is 3. And we keep doing that to find all the rest of the numbers in the Fibonacci sequence. So to break it down more simply, we start off with our first two values in our sequence, 1 and 1, and then we add these two together to get 2. And then we add 1 plus 2 to get our fourth sequence, which is 3. Then we add 2 plus 3, let's go 5. 3 plus 5 is equal to 8. So the first 6 elements in our sequence is 1, 1, 2, 3, 5, 8. And the sequence keeps going on.
Did you know that bees follow the Fibonacci sequence? This is because female bees can reproduce asexually to give birth to male bees. So let's figure this out. If you start with the male bee, that means that he was produced by a female bee. So the sequence is 1, 1. Now this female bee is produced by a male and a female bee. So the sequence becomes 1, 1, 2. Now this male bee is produced by just a female bee, but this female bee was produced by a male and a female bee. So our sequence becomes 1, 1, 2, 3. Back one more generation. This female bee was produced by a male and a female bee, but this male bee was produced by just a female bee. This last female bee in this generation was produced by a male and a female bee, which brings our sequence to 1, 1, 2, 3. If we go back to the last generation in this example, we'll have this male bee was produced by a female bee. This female bee was produced by a male and a female bee. This female was produced by a male and a female as well. This male was produced by a female, and the last female in this generation was produced by a male and a female. So if we count up the last generation in our example, we have 8, which brings the final sequence to 1, 1, 2, 3, 5, 8. If you keep going back in the generations of bees, you'll find that the rest of the generation numbers follow the Fibonacci sequence too.
Sarah, that's so interesting that bees follow the Fibonacci sequence.
Oh, I know. There's probably a lot of other things that follow Fibonacci sequence.
I'm sure there's like a ton of stuff around campus that follows the sequence.
I know, that'd be so cool.
Let's look over here.
I found an apple and a banana. I wonder if they follow the Fibonacci sequence. Let's see. They do. This apple has 5 seed openings for where the seeds can go. If you see real closely, 1, 2, 3, 4, 5. All right, let's see if the banana does. They do too. See, there's 1 slit, 2 slit, and 3 slits. So there's 3 slits all together. How cool is that? So now I'm going to see what else we can find on the slough that has the Fibonacci sequence.
What the? I knew something grew in the slough. Okay, so let's see if cauliflower follows the Fibonacci sequence too. 1, 2,
3, 4, 5, 6, 7, 8. It does. Cauliflower follows the Fibonacci sequence too. If the sleuth gods really want me to have some cauliflower, I guess I'll take it. But otherwise, I'm not much of a cauliflower kind of person.
Oh my gosh, look at what I found. I found lettuce on the slough. I guess I could come to the slough every time I want lettuce instead of drive all the way to High V. Let's see if it follows the Fibonacci sequence. Let's see, 1, 2, 3, 4, 5. It has 5 big leaf stems, so it does follow the Fibonacci sequence. I wonder what else on this slough follows the Fibonacci sequence. Let's go find out.
Are you serious? I thought pineapples were a tropical fruit. What the heck is it doing in the Quad Cities? Weird things are happening on the slough today. Let's see if this follows the Fibonacci sequence too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It does! It follows the Fibonacci sequence too. Let's see if we can find it in another place. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, that's a Fibonacci number too. I guess pineapples do follow it. This smells really good. I think I'm gonna go eat it.
What was that? Who just leaves peppers in the middle of the slough path? Let's see if they're Fibonacci sequence. 1, 2, 3. This one follows a Fibonacci sequence with the number of bumps on the bottom. I wonder if this one has it too. 1, 2, 3. This one does too. Wonder what else is on these peppers that follow the Fibonacci sequence. Let's see. 1, 2, 3, 4, 5. This top piece of the pepper has 5 little stems. So this does too follow the Fibonacci sequence. I'm going to go make some stuffed peppers with these since they're free.
So my friend Buster has offered us his hand to show how humans follow the Fibonacci sequence too. So if you look at your hands and you measure out the different joints in your hand and you ratio them, you'll end up with a ratio of 2, 3, 5, and 8. And then on my hand it would be 2, 3, 5, and 8. Isn't that awesome? Humans follow the Fibonacci sequence too.
What you just heard there was a chromatic octave, and it consists of 13 notes. And if you recall, that is a Fibonacci number in the sequence. So listen again. Now, if we break up the chromatic octave, there's 8 white keys, and there's 5 black keys. And both those numbers are numbers in our Fibonacci sequence. How cool is that?